This week we're going to have a look at stating whether a formula or an expression is a length, area or volume, and this ties in quite nicely to what we've just done in the lesson. Straight away, here's the rules or how to know whether or not something is a length, area or volume. The first thing you can do is ignore any of the constants or the numbers that are there. So 2 is a number, so I can just cross that out. I don't need it. Pi is also a number, 3.14, so I don't need that. And where I've got just one variable on its own, that one variable is always going to represent a length. And since there's only one variable there, this expression must represent a length. So, in total, this expression represents a length. Let's have a look at a few more. Right, so again, I can firstly see if there's any numbers, any constants here that I can remove. Well, pi is a constant, so I can cross that out. And I've got the variable in there, which is r. So on its own, that's a length. So it's a length squared. But a length squared is a length times by a length, which actually represents an area. Two things multiplied together are going to give me an area. So that must be what that is. Getting a bit trickier here, but first of all I can take off this constant at the front, this number, a half. And now I need to think about this a little bit more here. So each of these variables is going to represent a length on its own. So I've effectively got a length added to a length in these brackets, and I've got another length over here. Now, a length added to a length just gives me another length, or two lots of a length, so a length. And now I'm multiplying that by this other length that's outside the brackets. As we saw a moment ago, a length times a length is a length squared, and anything squared is always going to be an area. Okay, same rules. Remove the constant first of all. The constant's this thing on the front, the 2. Now each of these variables on their own is going to represent a length. So we've got here a length squared times by another length, and over here we've just got a length times a length times a length, which is a length cubed. We can sort this first bit out. A length squared times a length is a length cubed, added to a length cubed. Well, something cubed added to something cubed is still going to be something cubed, which is two lots of it. So this is going to be a volume. It's got 3 dimensions. If you wanted to, you could think of that as being 2 lots of the volume. And again, here's another one. Similar to rules. So cross the 2 out, cross the pi out. Then we can just look at the variables. R squared, or R on its own, is going to be a variable. It's going to be a length. So length squared times by h, which is also a length on its own. The length squared times by a length gives me a length cubed. And anything cubed is always going to be a volume. Let's have a look at this one. So we can remove our variables, remove our constants even, leave the variables, and pi. And now each of these individual variables is a length, so we've got a length times a length here, plus just a length, and length times a length on the end. So I could put these two bits together. Something squared adds something squared is still going to leave me something squared. Just 2 lots of it. But I can kind of ignore that. And then I've got this length on its own. So what we've got to do is say if this is a length, an area or a volume. And it's not actually any of those. It's not possible to add together an area and a length. or it's not possible to add together a volume and a length, or a volume and an area. So this is actually meaningless, doesn't mean anything. And usually you'll find in the questions that you have a go at in a minute, there'll be one option that you state that one of the little bits of algebra doesn't actually mean anything at all, and this is one of those. Doesn't mean anything. You can't put different expressions representing different dimensions together. Okay, last one. Same rules, so get rid of the constants, the number part. So we've got length times length times length on the top, which gives me the length cubed. On the bottom, I've just got a length. So length cubed divided by a length would leave me with, just using my knowledge of indices, that would just be a length squared, which anything squared must be an area. Have a go at the exam questions, they're attached.